San Diego Comic-Con. And this is a very impressive piece. So impressive that it has me on the fence as to whether or not I want to go back to collecting Star Wars. It's a gorgeous piece. It blew me away. It looks like a miniature movie set. It's that incredible. And I really kind of took my time here with the camera and fidgeting with the aperture because I really wanted to kind of capture the way it glowed with the lights. And it's impressive. This is the best. Using anything else to film it, and that nice, beautiful glow on the LEDs and the circuitry just come out right. So this blew me away. I going back over the footage, I'm like, wow, this is an incredible piece. You can almost imagine it, the Millennium Falcon as a giant 1/6 scale. It's impressive. It really, really is. And the fact that the Millennium Falcon is used in the new Star Wars Episode 7, this piece is going to generate some interest, and it's going to generate a lot of buzz. And it's really not that big. It takes up volume, but there's really, I don't think there's any excuse with collectors in the community stated that, oh, they don't have space. You can find space. This is one of those pieces that...
Alright guys, I thought that was kind of neat. It was a scaled version of the Millennium Falcon. So I thought that was kind of neat, and you see like models and statues like that, so I thought that was something interesting to talk about. Today we got problem solving in geometry with proportions. Yesterday we discussed what a proportion was. Today we're going to talk about it. Now I'm going to give you guys a fair heads up. This first part I want to share with you. It's just to kind of talk about a little bit. These are probably out of the entire unit some of the harder problems, just because it really makes you think. So I'm not too concerned. Don't stress yourself out if you're really struggling with this. That's basically what I'm trying to say. Okay. Here are two additional properties of proportions. If I have A over B equals C over D, you are allowed to replace C and B with each other. Like move the C down here and move the B up top. Okay? Because if you think about it, when I cross multiply over here, I get AD equals BC. And over here, I get AD equals CB. Multiplication is commutative if it works. So all you're saying is you can switch top and bottom from the opposite sides there. Okay? Now here's the interesting one. This is the one that really throws people for a loop. If A over B equals C over D, then A plus B over B equals C plus D over D. Let me give you an example. If I have 1 over 3 equals 2 over 6, you guys can all agree that's true. 1 over 3 is equal to 2 over 6. You are allowed over here to add a 3 to the top. Why? Because the 3 is down low. So it becomes this, 4 over 3. Over here, if I add 6 to the top, I get 8 over 6. Guess what? My equality is still maintained. 4/3 equals 4/3. I think what throws people off is the letters. I'm trying to make it a little bit more relatable with numbers. Okay, so let's take a look at some examples. Complete the sentence. If x over 6 equals y over 7, then x over y, notice they brought the y down low, so you bring the 6 up top, equals 6 over 7. Okay? All you're doing is you're replacing the y and the 6 here. Alrighty? That's all we're doing. Part B, if x over 3 equals y over 10, x plus 3 over 3, notice I add the bottom to the top, equals y plus 10 over 10. Okay, I add what's on the bottom. Just look back up here for the example if you're a little confused on that. Okay. If 7 over 2 equals b over c, 9 over 2 equals, well look what they did. They took the bottom here and they added to the top. 7 plus 2 gives me 9. So I'm going to do the same thing here. b plus c over c. There we go. Okay. Again, same idea, just with letters. I know it's a little confusing. Finally, I know up here it says you can add, the top to both sides. You can also subtract. Let's take a look at that. If 5 over 2 equals a plus b over b, then blank over blank equals a over b. Notice they took away the b. So I got to take away what's on the bottom here. Ladies and gentlemen, what's 5 minus 2? It's 3 over 2. Okay, like I said, I want you to see it. I'm not overly concerned. If you're really, really struggling with it, please don't beat yourself up over it. So same idea for number 2 here. If x over 6 equals y over 10, then x over y equals 3 over 5. So I'm assuming this is dropping down here. So that's to get me the x over y equals 6 over 10. Oh, but this is 3 over 5. But guys, you know how to reduce fractions down. This works, okay, because 6 over 10 is equal to 3 over 5. This is true. Okay, it's fine. Part B, if x over 3 equals y over 4, x plus 3 over 3, which this looks nice, I'm adding 3 to the top, equals y plus 3 over 4. What does this need to be? It needs to be the 4. This is false. This should be a 4. If that was a 4, it'd be true. Okay? Take a look down here. It's going to be much the same. If 7 over a equals b over 2, 7 plus a over a, that looks good, equals b plus 2 over, this needs to be what? It needs to be 2. The denominator never changes. So this is false. This should be 2. Finally, if 5 over 2 equals a over b, then 5 over a equals 2 over b. This is just switching these around, which is totally cool. That's your true. Okay? Wonderful. Use the properties of proportions. Okay? In the diagram, hj over jl equals gk over kl. So what I'm going to do, it says find gk. I'm going to go ahead and plug everything in. hj is from here to here. It's 6. So I'm replacing hj with 6. JL is over here. That distance is 12. I'm just looking at my diagram. Equals GK, I don't know. I'm going to call that X. Divided by KL is 10. Alright, this is a proportion, ladies and gentlemen. I have a fraction equaling a fraction. Okay, so you can cross multiply. One little thing to help you guys out, this might help you out in future events. Over here to the left, if you guys check out 6 over 12, I can reduce that down because it's just 1 over 2. Now when I cross multiply, I'm working with smaller numbers. If you want to do that, go for it. If you're fine the other way, it's fine as well. X equals 5, or in this case, GK equals 5. Okay. But again, that little trick right there, you can only do it for proportions. You can only do it top over bottom if you get lucky like that. Okay. Sweet. All right, on to your back. In the diagram, ST over TV equals WX over VW. So let's take a look. Find ST. ST is X, so I'm going to put X on top. TV is 8 equals WX is, now here's the thing. You have to do a little bit of thinking. I can figure out what VW is. VW is 9. I want this. Well, how in the world can I ever find that? Well, guys, look. They're telling us the whole thing's 21. This little piece is 9. 21 minus 9 gives me 12. That means this piece has to be 12. Okay? So it's just 12 over 9. Again, if you would like, you can reduce this down 4/3. So x over 8 equals 4 over 3. Cross multiply. 3x equals 32. Okay? And then divide by 3. I get x equals 32 over 3, which I'm totally fine if you guys leave your answer like that, or 10.66. I will accept both. Again, I'm hoping I can keep pushing you guys to go further and further towards improper fractions. Joe has relatives in Russia. He decides to take a trip to Russia to visit them. He took $500 US to the bank to exchange for Russian rubles. The exchange rate on the day was 35.96 rubles per US dollar. So rubles over dollars. And the rate was, what do we say, 35.96 over 1. Okay, so $1 ruble. Let's see, how many rubles did he get in exchange for the $500 US? He had $500 US. You have to keep the same thing on the bottom. So notice I had $1 US down here, $500 US down here. I don't know how many rubles I'm going to get. I have to cross multiply. X times 1 is X. Okay, 500 times 35.96 gives me 17,980, and that's in terms of rubles. Okay, I don't have to divide by anything, it's just, there he is. Okay, I don't know if that exchange rate is still true to this day, but you get the idea. Alright, Geometric mean. You guys are going to do this without even really knowing it. The geometric mean is the square root of the product of the two numbers. Product means multiply. All you guys are doing is you are multiplying these together, and you are getting a number, and then you are square rooting it. So for 8 times 18, I get 144. And I then square root it. Square root of 144 is 12. Okay? Let's see here. 7 and 28. 7 times 28 gives me 196. Square root that. I'm going to try to break this down. So I'm looking for a perfect square that goes into 196. It's actually going to be 49. Oops, sorry. What am I doing here? My apologies. It's just 14. Okay. 3 and 27 gives you 81. Square root of 81 gives me 9. Finally, 8 and 20 is 160. I can break that down to root 16 times root 10. I'm looking for perfect squares. If you guys ever need a perfect square chart, that'll be on the board. Perfect square root of 16 is 4. Square root of 10 is 10. Boom. Okay, you guys should know that. The two buildings shown have the same width to length ratio. The distance labeled x is the geometric mean of 105 and 210. Find the value of x. Just to show you guys how this is set up. Okay, it's telling you it's geometric mean, so I know I'm going to have to multiply these two together and square root it, but I can do 105 over x. Notice I'm doing width over width, and then I'm doing height and then height. So 105 over x equals x over 210. Okay, so I'm cross multiplying here just to show you guys how it works. Ladies and gentlemen, x times x gives me x squared. 105 times 210. 2250. Okay. Now I know in the last problem I broke this down, like if we squared it left and we squared it right, we broke it down. If you're talking about the height or the width of a building, never am I going to be like, oh, I want to see perfect squares broken down. So square root of 22,050. We get, let's see here, let's round to the nearest hundredth, which is the 2 decimal places. 148.49. What are we talking about here? We're talking about meters. Okay. But yeah, you would never give like a perfect square being broken down. Like I wouldn't do. You get the idea. So make sure you guys include units. Always remember units. Okay. Because that is a big deal, especially when we're talking about height and width and so on and so forth. So that's that is one. Well, we got a bunch of different ways here we can use to proportions to our advantage. Okay. Again, I really want you to focus on pretty much from number 3 on. As far as the stuff up here, please keep trying with it. All right. Give it a go because those properties will definitely help you and it makes you kind of think abstractly in mathematics. But otherwise, you guys should be in good shape. So, as always, keep up the good work and good luck. We are all counting on you.